Okay, so here's the plan. This gigantic RC car has been sitting in the basement for a few years now. And the problem is it has no remote control, which means I have no way to drive it. I'm going to try to hack this and make a custom remote control. Let's see how this goes. Okay, so I got really lucky and actually found the schematic diagram for the RC car on the FCC database, I think. So here it is. This is only the receiver side, so I don't really have an idea of what the transmitter looks like. But after a quick search, this popped up. So the circuit is really not too complicated. We just have this radio chip right here that receives the signals from the antenna, which is right here. And it basically sends all these signals to different parts of the car. For example, right here is an op amp and H bridge connected to just the drivetrain that allows the car to move forward and then backward. And then right here is some power step-up voltage circuits to deliver a high voltage to the H bridge and the op amp here. And then down here, I think, is a servo circuit. As shown right here, this is probably the front steering with a potentiometer to measure the actual direction, and then the motor to control the turn of the wheels. So here's the general idea of what I'm trying to do. Looking at these two markers here, I see F and B, and then same right here. So these two are connected, F, B, B, and then F and F. So what I'm going to try to do is I'm going to apply a voltage to these points and also these 2 points right here, 5 and 10 on the bottom, as each of these op amps correspond to each driver on the H bridge. So by turning on diagonally, so either this and this on or this and this on, I can essentially turn the motor forwards and backwards. So that's what I'm trying to do. I'm going to solder some wires and let's see how this does. So I soldered 2 points on this PCB here, as you can see with these 2 wires here. This chip right here, I believe, is the radio communication chip. And this chip here is the op amp, the LM324. So these 2 points directly are connected to the op amp, which drive the H bridge. And I'm going to try to see if I can get this thing to spin. Okay, so I actually got the motors to spin. Now the next step is to figure out how to get the front steering to turn. So I'm guessing it's a servo type circuit or control protocol. So first I'm going to try to experiment with the small servo here and then move to the big steering system in the front. Okay, so for some reason, doing the servo motor took way longer than it should have. I kind of realized that I think this is the first time I've ever written a servo motor program on 8051 type MCU. Well, after about 3 hours of work, I finally think I got it. So here we got the microcontroller right here. And then this is connected to the servo, obviously, which is finally spinning now. And I've also attached an oscilloscope showing the wave growing larger, as you can see here, and then smaller. Okay, so after doing that with the small servo, I'm going to try to do this with this big servo of the RC car. So right here is what I believe is the servo controller. And I say I believe because I can't find any data sheets for this chip right here. And it is connected to this radio chip with only 1 wire. So my best guess right here is that it's a basic hobby servo protocol. And I'm going to trust that that is what it is, because if this doesn't work, I'm going to have to try some deep hacking here. Okay, so I'm going to clean up the desk and put this gigantic RC car back on and see if the steering spins. And see if my assumption of having just a normal servo protocol is right. Okay, so I plugged the power in, and nothing. The light lights up, LED lights up, but still nothing. It doesn't turn. I checked the wires, something's wrong. So this is the plan I eventually went with. I'm going to essentially basically bypass this chip here
and I'm just going to directly use this as a motor driver and connect the microcontroller to this pin to figure out what actual angle this steering is at. And then use these two pins right here to drive this motor and just essentially create my own servo controller. Okay, so this is going to be interesting, but let's see if this will work.
Okay, it's currently 1 o'clock in the morning right now, and I think I might have figured it out. So here's the setup right here. We've got the RC car propped up again, and instead of using the SDC microcontroller, I switched it to an Arduino because just of ease of use, and I realized that it actually doesn't take three. It doesn't matter if it takes like a 3.3 volt input. 5 volts also works. And we have a bunch of wires connecting it to the PCB. And then on the left here, I have my laptop with the Arduino ID serial port up. And what it's supposed to do is if I send it two numbers separated by a comma, the first number represents the servo angle, and the second number gives it the PWM speed of the drive motors. Okay, so I'm gonna send it a set to, let's have it just turn the steering right now. So set it to 120 degrees. Speed. I'm gonna switch it back to 90. And then the other way. And then now I'm gonna try to test the drivetrain. So let's see, this thing can start spinning. So let's set it to normal steering, and let's just nudge it a little bit forward. And it works, yes. Let's get it faster. And then it stops. And then let's try the other direction. Okay, let's go. Yes, it works. Okay, the next step is going to be trying to figure out how to connect the 315 megahertz transmitter receiver pair with the Arduino and make a remote. But that's a task for another day because I have to get some sleep. So, see you tomorrow.
Okay, it is a new morning, so let's get some breadboarding done. Okay, so I hooked up the receiver and the transmitter with two Arduinos and two of the modules. But if you look at this data here, coming from the output serial of the receiver, you see that there's a lot of inaccuracies, like fluctuations in the data. I believe this is caused by the noise, which I think would be a big problem. So I need to figure out a way to add some checksums to kind of go around this noise problem. I found this Arduino library called Radiohead, and I think it kind of fixes all my problems because it has all the checksums and all the stuff built into the library, and I can just use its send and receive functions. Now let's see if this works.
Okay, after a few days of work, I think I might have finally got it. Okay, so right here next to me, we have the transmitter connected to an Arduino. The first pot you see right here is a pot to control the angle of the steering of the front. And this pot in the back here is the pot to control the speed of the motors. Okay, let's now see this thing in action. Okay, so right now I'm controlling the steering. Here, every time I turn this. And then I've had this thing spin and start moving. I can turn the second potentiometer. Okay, now let's have this spin the opposite direction backwards. So yeah, there's the RC car and my newly created remote control system. Right now it's still a prototype, obviously, but I'm planning to maybe create my own H-bridge because I know some issues with current draw. So there you go, a little bit into my journey to fix this RC car, and I hope you like this video, and see you next time. Bye.